Good morning, ladies and gentlemen. Thanks to the jury and the panel members for being here. It is my privilege to welcome you all to this presentation. I am Shilpa Singh, working for Engineers India Limited. And today I would like to present on a digital operational excellence software developed for heaters. The name of the software is ENGRT-HTR, where RT stands for real time and HTR stands for heater. Now, 2023 being a year of innovation for Engineers India Limited, we have treaded into less traveled areas like digitalization in various sectors, and heaters is one such sector. I hope the slide is moving. These are
yes, ma'am, moving. Please go ahead.
Okay, thank you. This is the outline of the presentation, the areas which I would be covering in my presentation. So I'll quickly move on to the next. Since the focus today is on fired heaters, these heaters have been in existence for time immemorial. I have been working in heater area for 25 years. EIL has been working for more than 50 years. In fact, Digboy Refinery has completed more than 100 years of operation, where heaters have been working since the conception. And in many installations, these heaters are still decades old. Lots of revamp and improvements have occurred, but all the heaters have not been replaced. When these were installed, probably in those times, the technology was not that much evolved. So the efficiency of existing heaters is not that high. There are multiple reasons. Probably the operating cost of fuel and the other OPEX considerations were not into picture. The statutory guidelines were not that stringent. So the emissions were not in picture. And in all this, the efficiency was not the prime concern. But with moving times and in current scenario, efficiency is very, very important. It is not just the fuel which we want to minimize, it is the emissions which we want to minimize. The target these days is actually net zero. But can we really go to zero when we talk of emissions from furnaces or fired heaters? To understand that, let us look at the bar chart here, the pie chart on the right side. In any fired heater, typically there is a radiant section which consumes 60% of the fire duty, 20% is absorbed in the convection section, another 9% is absorbed in metallic air heaters or heat recovery sections, which have come into picture in recent years. Then the technology evolved and low temperature heat recovery systems also came into picture, where another 3% also could be absorbed. 2% in orange is the heat loss, surface heat loss. You cannot do away with that. It is always going to be there. Then remains the 6%, which is actually the stack losses. Stack losses are happening because there are hot flue gases going into the atmosphere. It is this narrow zone where we need to play whenever we are talking about operational excellence or efficiency improvement. So in this narrow zone, what can be done? Till we can go for complete makeover of a heater, it is very wise to go for operational efficiency improvement or excellence. To do that, we need to understand what are the key areas or the concern areas in a fired heater. Some which we have identified and which we have addressed in the software are fuel sulfur content. Anybody who has been in refinery sector would know that initially most of the fired heaters were operating on heavy fuel oil. Then we moved on to lighter fuel oils. These days, many furnaces are operating solely on fuel gas. And in future, we are talking about moving on to fully hydrogen-fired furnaces. So with these changing fuel considerations, how the heat recovery and how the equipment operation should be adjusted, it is very important to understand and predict that. Excess air is another such parameter. When the fuel is changing, the air demand changes. So on real-time basis, how can I calculate that excess air? This software is capable of going to do that for you. There are process variations happening because my product quality has changed in refinery, although my equipment may be same. The configurations of the refineries have changed. At places, these have been integrated with petrochemicals. So the process demand in furnaces has changed. With these varying process demands, it is important to understand how the operation of the furnace is also required to be adjusted. There is one parameter, ambient condition, which is usually ignored because this is something which is relevant for areas where there is wide variation in ambient temperature in summer and winters. There are places in India itself where in winters the ambient is going to be of the order of 2 degrees C, and in summers it is going to be of the order of 45 degrees C. With this variation in ambient temperature, there is a potential of heat recovery which I can maximize in summers, and probably I may need to lose some in winters. In any digital intervention, there is a golden rule. You cannot optimize that you cannot measure. So it is very, very important that the parameters are measurable. Engineers India Limited has stepped into that field and developed this software NGRT, which is developed on the backdrop of more than 400 fired heaters, which we have designed. And there are lots of improvement studies and troubleshooting assignments we have undertaken. The point of mentioning this here is that there is lots of know-how and lots of data bank available in EIL, with the help of which this IoT-based AI tool has been developed. It is a plug-and-play dashboard. All the feedback has been built into it. It can be installed anywhere, utilized anywhere, and it will be able to identify whether the efficiency of my system is optimum or not, whether my system is operating in safe zone or not. Now, what do I mean by safe zone is that we have found in industries that sometimes efficiency takes precedence and we may be operating our furnaces in unsafe zone. Unsafe zone is something where we are operating in at temperatures where corrosion is happening and corrosion is damaging the equipment. The software is able to identify and warn the user that such an operation is not warranted. You have to always operate in the safe zone. You have to keep an eye on CO emissions. You have to keep an eye on the corrosion happening into the system. Now, some measurable parameters which go as input into the software are fuel specifications, fuel flow rate, because this is something which we are trying to optimize. Excess air measurement has to go into the software because we will be manipulating the excess air. Damper settings are there for both stack damper as well as air side dampers, fan capacity, stack temperature, ambient conditions, and other permissives like how much should be the CO allowed. This would be the statutory guidelines can be built into these other permissives. NGRT HTR software will optimize these. It will evaluate, it will let you know where your system stands. It will give you recommendations what you can do with your excess air to trim it further. What adjustments can you make into your damper settings? What would be the improved efficiency value once you make all these adjustments? What would be the stack temperature, the most optimum stack temperature for the current fuel conditions, for the current process duty, for the current ambient? It will let you know whether any preventive maintenance is required. Like I said, if the furnace is operating in danger zone, it will let you know what corrections you need to make so that your system remains safe at all points of time. Another important thing which the software will let you know, if the potential is there in flue gases for heat recovery, but somehow my hardware is limiting. Hardware could be my air preheater. Let us say it could be undersized. It will let you know whether you need to make changes into your hardware, whether you need to make some capital investments to utilize maximum potential from the heat recovery system. So what we achieved for doing this hardware modification to seek current status of the efficiency and the improved efficiency difference, then to protect the equipment, to modulate the parameters, all this is achieved by opening either the stack damper, by maintaining best flue gas exit temperature, by APS bypass damper settings. So this all we can do in this software, and it is a simple Excel based worksheet wherein you can feed the data. Any user can open this Excel based worksheet Wherever there is an internet connection, they can feed the data. It is very easy to use. All the measurements are taken either from DCS. We can link it to DCS directly. All the input data can be mapped directly, or it can be fed manually. And in the simplest form, the units can be adjusted as per client requirements, as per their convenience. The software will do the calculations, it will evaluate, it will summarize the input parameters, it will give the current status of the equipment, it will let you know, like in this case, in the center, we can see that for FD fan regulation, software is recommending to reduce the excess air, and it will let you know what the efficiency, it is reported below the green column. The efficiency potential of 1.33% we can see, and equivalent fuel saving, how much is the equivalent fuel saving and how much is the equivalent CO2 reduction, that all we'll be able to know. These are the snapshots of two software installations which have happened, in one in South India refinery and another in North India refinery. If you go into further details of these success stories, for this first case, there was an efficiency improvement of almost 0.5%, and annual fuel saving of 264 tons, and the OPEX benefit of around 126 lakhs per annum. So that means with this plug and play tool and with nil investment in hardware, it is very important to note here that we are targeting the lowest hanging fruit. There is no investment in hardware modifications. It is just adjustment of the operating parameters. With that itself, we are able to reduce our fuel consumption significantly, as well as we are able to reduce the CO2 going into the atmosphere significantly. This is another case study. There is another important point here, that an anomaly in air measurement could be identified. So in that way, this software acts as a tool for reconciliation of data. It is a predictive tool for performance evaluation. This is something which our industry or the fired heater industry needs, really needs these days. In this particular case, there was saving of 1.2 million US dollars, and then there was maximum possible utilization of asset, and further could be done by capital investment. This is the certificate issued by one of the happy customers. We are happy to say that this software has been installed and it has done what it was supposed to do. The changes, if we extrapolate this study to a refinery, complete refinery level, a typical 9 MMTPA refinery may have all these furnaces. These are typically crude, vacuum, VGO, DHDT, heater, feed heater, reboiler, and the typical duties, if these are of this order, then we end up saving almost 1200 tons per annum of fuel, and greenhouse reduction is 3520 tons per annum. To summarize, it is a affordable plug and play tool, no hardware investment. It can be, evaluation can be done any point of time, as frequently as you want. You can do it daily, you can do it weekly, you can see the results right away. You can make the adjustment as per your convenience, because the adjustment in operating parameters or damper settings is required to be done by the operator. Intentionally, this has not been integrated with the DCS system or the DCS interlocks control system, because we want the operator to take a well-informed and controlled decision. These most of the furnaces are susceptible to damage if sudden changes are made into them. So all the liberty has been left with the operator, and it is a Make in India initiative, and it has been in operation for almost 1 year now. It is a big leap towards net zero initiative of EIL, as well as it is helping in net zero initiative of all the industries which are utilizing fired heaters. There is a huge potential if we extrapolate to the whole refinery sector of 200 MMTPA in India. then there is a potential of saving almost 33,000 tons per annum of fuel. And this applicability of this software can be extended to other industries. Till now, we have utilized it in refinery sector. This can be extended to other industries like steel industry, paper industry. Wherever we have fired heaters, it can be extended to all those industries. And it can be used as a tool to identify whether there is any debottlenecking in the furnace. We have used it as an energy audit tool also. And for last and most important is, for the user, it is able to let you know the benefit in qualitative terms as well as in quantitative terms. The qualitative is whether you can go for hardware improvement or not, and the quantitative is that you are able to know right away how much fuel is saved, how much CO2 is reduced, and how much saving can be done in terms of power of fans or dampers. So that is all from my side. Thank you to the jury, and if there are any questions, I would be happy to answer them.
Thank you, ma'am. Very good innovation. Excellent presentation. You have achieved efficiency as well as reduction in toxic gases in the flue side. You have indicated that this can be applied to other industries. Can it be apply this software to power sector industry, coal-fired station? Number one. Number two, what is the roadmap for switching over to the hydrogen firing heaters?
Actually, yes, these are. Thank you, sir, for the very important question. Yes, it is intended to extend this to other furnaces. The science or the theory behind this software remains the same. There are some adjustments we need to make for the permissives part, because coal firing is different from fuel oil or fuel gas firing. But that kind of flexibility has been built into the software. As a first step, we developed it and offered it to refinery. And yes, we are ready to make adjustments to tailor made it, to customize it for other industries also. The second part of the question, hydrogen firing. Right now, it is in partial hydrogen introduction into the fuel gas header, which is already taking place, because we have to reduce CO2 as much as possible. So we are moving towards lighter gases like RLNG, and some introduction of hydrogen into the fuel header is already taking place. In future, or like in coming times, this hydrogen is going to be converted to green hydrogen. Like IOCL has already announced installation of green hydrogen plants, that green hydrogen would become part of the fuel gas header. So slowly and slowly, the percentage of hydrogen in fuel is going to increase. 100% hydrogen is something which is still being studied at research level. The burner suppliers, the equipment suppliers, all are party of that study. And since it is not commercialized yet, so that progressively things will emerge, and eventually to achieve net zero, we may need to go for 100% hydrogen, or to other sources of heating like electrical heating in furnaces.
Thank you, ma'am, please. Thank you, please. Excellent innovation.
Thank you, sir.
Ma'am, energy audit is a very routine matter for energy intensive industries. So your work seems to be very generic in nature to me. So what is innovative in this? Simply your software is streamlining how much fuel should go and how much air should go to supplement it, so that the consumption is optimized. What is innovative except this?
Yes, sir. I would, for this, thank you. I would like to bring one difference which is there in this software as compared to rest of the software commercially available and installed already in the refinery. Yes, you are correct, sir. Lot of digitalization has already happened in the industry. There are worldwide commercial softwares available worldwide. But most of these softwares work on the, like if I take the example of refinery, these softwares work on the aspect of process heat distribution or process feed distribution, which would eventually affect the overall fuel consumption in the refinery, or energy consumption. It could be power, it could be steam, it could be other utilities as well as fuel. Nothing has been developed yet for optimization on an equipment level, because this evaluates the operating parameters. Once that process duty has been suggested by the other software, which is a globally available software, this will evaluate what the current status of the system is, which no other software is able to do. And operating evaluation is something which cannot happen if there are no feedback built into the software, no predictive tools built into the software. So all these predictive tools concised together to make them available at one place, to take help of all those predictive tools to predict the future, what will happen. That is something which is innovative in this software, and it allows you to make the adjustments without compromising on the safety. So that is one thing, and without compromising on other premises of the statutory guidelines. So that is something which is doing things on equipment level, and that too on operation level is something which is innovative in this software.
Thank you, ma'am.
Thank you, sir.
Good morning to the jury and good morning to the esteemed jury and all other present in meeting. So, am I audible clearly?
Yes, sir, you are audible.
Okay. So, we are going to present a very new software which EL has developed. The software is called Inch CO2 Chitran. So, it is an indigenously developed software for calculating the CO2 equivalent or total CO2 emission mapping. And this has been developed by EIL's team for digitalization initiative. So with me, in our team, Mr. Rajshekhar and Mr. Rajiv Nan is there. So though I'll be speaking, this is a totally team effort, and entire team participated in different ways to develop this software. So we are going to talk about the different aspects of this software. So as we'll discuss the uniqueness, the challenges we faced, what are the excellence came out of this project, and scalability and replicability of this software, and the future roadmap, along with the references we used for developing this software. As we know that global warming is a big concern for everybody, and the Paris Agreement decided that to limit global warming to 1.5 degrees centigrade, some targets to be set, like emissions need to be cut by roughly 50% by 2030, and net zero target we should reach by the middle of 21st century. So this was in 2015. So then we came to COP26 at 2021 at Glasgow, Scotland. There, India declared its commitment to go net zero by 2070. And subsequently, various initiatives taken, like SEBI, through a notification, made it mandatory for top 1,000 listed companies by market capitalization to furnish their Scope 1 and Scope 2 green green gases like CO2, methane, all these emissions from there in the annual report from financial year 2022-23 onwards. And it made it voluntary for other companies who are not in the top 1,000. So this was followed by many Indian companies. They declared their net zero emission target. Like as we can see in the top right corner, EL has also declared our net zero target, which is 2035. So now we have to understand the process of going to net zero. So when we are going to net zero, first we have to understand what is our CO2 footprint. Because if we do not know what is my CO2 footprint, then I cannot plan in different stages how I'll go to net zero. So if we are not sure about my net zero footprint, and I do calculations in different methods, taking some input from some sources, some input from other sources, then it may happen that after some time that we find that in our calculation, some CO2 footprint or some CO2 emissions are missed. So when we find that, we have to again revise our strategy, revise our plan towards net zero. So we have observed that there are different organizations. We discussed with them how they are doing their net zero emission calculation. We found that different companies are following different methodologies. So there is no unified approach, and like some are calculating from fuel, some are calculating from the electricity and others they are getting, and they are summing up. But there is no unified platform for doing these calculations. So we thought that it will be very good for Indian industry if an unified tool which calculates these CO2 emissions, and in one platform it gives the CO2 footprint calculated from different sources and under different scope 1, scope 2 and scope 3, so that they can, from that they can get their CO2 footprint. Now coming to the uniqueness of the software which is developed, it is first of its kind indigenous digital web platform for CO2 equivalent emissions calculations specific to Indian refineries and Indian needs. So which will highlight that this is very, very specific to Indian refineries and Indian needs. Because when we started in our development approach, we found that there are certain fuels used in Indian refineries and which are not available in the fuel emission calculations international softwares available. So we had to work with the various data we have with Indian refineries. What are the different fuels available in Indian industries, Indian refineries, and we calculated and we found out that what will be the CO2 emission or CO2 equivalent emission for those fuels. Then as we discussed that it is in single platform, it calculates scope 1 and scope 2 emissions. So presently it is not calculating the scope 3 emissions. So our target is to include the scope 3 emissions also in near future. We are working on it, and we'll discuss subsequently that what are the challenges we are facing in that and how we are planning to include scope 3 in our platform. And I'll just mention here the present SEBI guidelines. They do not include scope 3 emissions. In the annual report, they're asking only for scope 1 and scope 2 emissions. So while doing this, we had to use EIL's in-house data and knowledge for process CO2 emissions. Because when we are trying for doing these calculations and getting this platform ready, we found that the process part is missed in most of the calculations followed globally. There are fuel-based calculations, there are electricity-based calculations, there are steam-based calculations, there are different fire suppression agents calculation based on that. But in the process of a refinery, also there are CO2 emissions which are missed in many of the calculations available. So we try to bridge that gap. So we have with our IT team fully involved in this. So we have made a digital data input platform with advanced dashboard. So we have built in flexible options for data input, because we understand and we recognize that the different companies and different refineries, they have their record of the past data in different formats. So if we give a platform or if we give a software which asks for data input only in a particular way, they may not be able to use it. So that's why we have kept different options for giving the data input. Another very important aspect is the double accounting. So we found that there is scope of double accounting in some of the calculations. What we are taking care in while we are doing the emissions from fuel, there is a chance that that emission is replicated when we are doing the emissions from process. So we identified those places and we have taken proper cautions, and we built in our software that double accounting is should not affect the calculation. And we have ensured that our software is aligned with global protocols, standards, and Indian regulations, which will give the detailed references what we have used at the end of our presentation. See, another important aspect is in our platform, it gives the graphical presentation, the emissions from different areas or different fuels. So the owner can plan their strategy. They can know that what are the factors for their plant which are creating most pollution or most CO2 emissions. So they can, while they are targeting their CO2 emission path, they can fix that, like in these areas we have to focus more, or we have to reduce the CO2 emissions, these areas on priority. And as it is a web-based platform, multiple users can feed their data input easily from accessing it from different location. So it saves a lot of time in data input. So it also provides year-wise trend of CO2 emissions. These can be used to verify the progress towards net zero. When I'm planning a net zero target, I am fixing that in 2 years, my net zero, my CO2 emission will reduce to this, or next after 5 years, it will be like this. So with this, we are giving some trend. So with that trend, it can be understood that whether we are going as per our path, or there is our target is not achieved and we have to focus on something. We have provided enterprise-grade security for the data management. So some of the data are very sensitive in nature, and many companies would not like to find that their particular refineries CO2 emissions data or some other valuable data is available in the to sources which will be harmful for the interest. So we have ensured that in the portal. And so report of Scope 1 and Scope 2 CO2 emissions can be generated to comply with SEBI regulation. So while we are making the reports, we ensure that SEBI is asking the data in certain manner. So our reports also should give the data in that manner, so that easily they can comply with their annual report, that CO2 emissions, what SEBI is asking, they can fill up in that particular way. And we believe that this will be a very important tool, and it will accelerate India's journey towards net zero targets, because it will help many of the industries to, in one platform, they can calculate the comprehensive CO2 emissions, and accordingly they will be able to make their plans, and that plans also they will be able to make more realistic, and they will be able to achieve those. So I'll show a few screenshots of our software platform. So this is the login page. So here you can see, like it is calculating. Basic idea is given what is Scope 1, Scope 2, and Scope 3. So and after logging here, we can go to the next screens. So this is the dashboard screen. So we'll find that this screen has 3 grids. So in the leftmost grid, it gives, like, we have made it as a sample case, and for explaining, we have given the data from our in-house information for a 13 million MMTP refinery. So the assessment year is 2021-22. and turnover of the refinery is also given, and the complexity factor of the refinery, that is also given. So we can find out what is the summary emission. Scope 1 emission is this much maximum, followed by scope 2, and scope 3 is presently not being calculated. So that's why the figure is not coming. And at the bottommost part, these are the different parameters in annual report which SEBI is asking, like the CO2 with compared with the throughput, and CO2 with throughput and NRGF, and the net CO2 with the turnover. So all these figures we'll get from here. And here we are getting in the middle part, we are getting the graphical presentation of the CO2, how much is scope 1, scope 2, scope 3. Scope 3 is presently not there. And there we are giving two important donors which give the contribution of CO2 coming out of the different areas. Like this one is given from the different fuel type, how much CO2 is coming, how much contribution of different fuels. And this one is giving the breakup of scope 1 emissions, scope 1 emissions being the major contribution here. The different, like what is the fuel combustion, what is the part of that. Then refrigerant leak, what can be the contribution of that. Then for say for transport, the mobile company-owned vehicle, what will be the contribution of that. Coke combustion, what can be the contribution of that. For flaring, what can be the contribution of that. And here we are giving the graphical trends as I was discussing. We can know that how my CO2 emission is going over the years. And with this, we can see that how closely we are following our CO2 net zero target. The next screen is giving some detailed view, like the calculations. In this screen, in the scope 1 emissions, like we have scope 1, scope 2, scope 3, the data will be entered through the different pages. And these different, under scope 1 also, there will be various sub pages, similarly for scope 2 and scope 3. So scope 1 emissions, we have divided into 4 different segments. So first one is the stationary combustion, which is mostly based on fuels. And here I'll emphasize that we have established that all the different fuels in Indian refineries are included. So which you will not get in any international platform as on date, that all the fuels in one particular software are used in Indian refineries are the CO2 emissions is given.
Sir, sorry to interrupt you. Please conclude.
Yes. Okay. So then we are showing the remaining screens and the various challenges we faced, that also we are showing. Like we found that the different refineries are having the different feed and products, and some refinery specific fuels are there. Then there is a double accounting. All these things what we discussed here, that we have shown in the challenges. So then the excellence of the software, that also I discussed earlier. I'm just again, we have shown here that it accounts for the total in one platform. It gives the comprehensive report, and it presents data in the very graphical manner, which will be useful for the users. So this software is modular in nature, so it can be easily used and expanded to the other industries. And we are very closely, we are issuing it for the for buildings also, and we'll be following up with other industries like petrochemicals, then refineries, and we'll be also taking for steel and cement. And the future roadmap, what I have discussed, that we'll be going to include the detailed scope 1, scope 3 emissions, and also will cover the different other segments of industry. So these are the references and standards, international and Indian regulations we have used for developing this software. Thank you. So I'll be happy to answer any questions.
Thank you, Mr. Saket. I think this is a very good innovation. But in how many refineries you have introduced it so far? And what is your program to introduce it in remaining industry, remaining refineries?
Yes, sir. Thank you for this question. Actually, we have not used this software in presently in any refinery. While developing this software, we have taken data from different refineries, and the data just now I explained that was from a particular refinery in India. I will not name it. And this software during the recent India Energy Week also, we have displayed this software, and we have many of Indian refiners, they are interested in using this software. So we'll be offering this very soon.
Okay, okay. It means this is still at the R&D stage or concept stage. It has not been rolled out in any refinery.
Yeah, it has been developed. The software is developed, but like you have proposed this for one of the refinery, they have asked us to give their CO2 for their CO2 target. They have asked us to give the consultancy. So there we have given it because in that CO2 net zero target, there are two phases. In the first phase, the proper calculation of CO2 footprint is required. And in the second phase, the various measures for going to net zero is there. So we are giving the proposal for the both the phases. For the first phase, we have proposed in our proposal, this software is included.
Okay, okay, okay. Then secondly, you have mentioned the SEBI regulation in your presentation. SEBI is
Yes,
an NBFC regulator. What is the full form of SEBI?
SEBI is a Security and Exchange Board of India, who
But
are controlling
how they
this.
are how true? But how they are concerned with this carbon dioxide data?
Yes, actually, the commitment the government of India is given, like under Prime Minister's that Pancha Amrit in Glasgow, there we have given a commitment as a country, India, our net zero target will be made by 2070. So various government organizations are creating an atmosphere and various measures that how the country can fulfill. So in that process, SEBI has also come in. So SEBI has given that the top 1,000 companies, and many of them are energy intensive industries, they should declare their present scope 1 and scope 2 emissions, so the country can see that what is our emissions. And if you can see that in one screen I have shown, India as a country is presently the third largest emitter of CO2, though our per capita emission is less. So that's why there is a role of different government agencies, and all together we have to achieve this target. So in that, SEBI has come.
Okay, okay. Thank you, please. Thank you.
Okay, thank you.
So what do you mean by double accounting of emissions?
Yes, sir. Thank you, sir, for asking this very interesting question. Actually, when we have done in our CO2 calculation software, we have found like while we are there are some CO2 emissions are coming out from the fuels, so we can directly calculate the fuel CO2 emissions. But then we know that there are some processes which also generate CO2. Like in the hydrogen plant, there are some processes which generate the CO2. And why we have given the calculation different options. So there we found in the sum of the options, if we are using the give the data in a particular manner, so there the fuel calculations that is also included. So if we, while filling up the data for my hydrogen units in my refinery, if we use that option, we have to subtract the fuel part what we have considered in my fuel or my fuel emissions page. So otherwise there will be double accounting.
Okay, fine answer. Thank you very much.
Thank you.
Thank you very much for giving us the opportunity to showcase some of the works which we are doing through your this award features. We will be sharing you the experiences of a very mega HVDC project which was executed in 2021. We'll be talking about the new technology which Power Grid introduced in India. in Pugalur Trichur 2000 megawatt VSC based HVDC system. So this slide will show you how the project has been conceived and been done. This project is basically meant for providing the power to the state of Tamil Nadu and state of Kerala. A total power of about 6,000 megawatt plant to be evacuated from Raigad in Chhattisgarh district, Chhattisgarh state, to the southern states like Tamil Nadu and Kerala. The share of Tamil Nadu has been 4,000 megawatt, and the share of Kerala is 2,000 megawatt. So once the power comes from Raigad to Pugalur, traversing a distance of about 1900 kilometers, then this power from Pugalur in Tamil Nadu is pushed to Kerala. So this is done through a plus minus 320 kV Pugalur Thrissur 2000 megawatt voltage source converter based HVDC system. This was the first time when we got introduced to this kind of technology in India. This involved 138 kilometer of overhead lines and about 27 kilometers of underground cable. The highest voltage is 320 kV. It was approved in 2017 and got completed in 4 years' time. The major beneficiaries has been Kerala, and as it provided a grid security. As on date, it provides 45% of Kerala's peak demand of 4,370 megawatts. When we constructed this project, we ensured that the bare minimum forest area is affected. So only 1.22 kilometers is affected. This is just a brief diagram of how the things are technologically, how the things have moved from the Raigad. It is shown that AC system from the Raigad generation is getting pooled at Raigad cooling station. From that generation, it is pushed through a HVDC link at 800 kV HVDC, and it's a bipole link which pushes the 6,000 megawatt DC power to Pugalur, and from Pugalur it gets disseminated to the load centers in the form of a DC line in the state of Tamil Nadu and into Kerala through this voltage source converter DC link. And in Kerala, again, it gets moved to the load centers through AC lines. So why we have adopted this VSC technology? It requires very low land. It has a less ROW. It has the controllability of active and reactive power in the bidirections. It has the black start capability, the cable transmissions through XLP cable, and it is suitable for low short circuit capability network. So what are the applications? Underground, it's cable or sea cable transmission. It can use as a combination of cable as well as a line transmission. It can provide the point-to-point HVDC up to 2000 gigawatts and up to plus minus 500 kV of DC voltage. It can connect the V grids, wind farms, solar farms. The uniqueness of this project, it is the first of its kind in India. It has the highest underground cable DC voltage level, that is plus minus 320 kV. It is the first VSC HVDC project with a combination of overhead line as well as the underground cable. It controls both active and reactive powers simultaneously. And with the optimal route selection, we have minimized the environmental impacts. So the total forest involvement is about only 0.74% of the total line length. It carries the bulk power of 2000 megawatt from Pugalur to Kerala. So it has the flexibility in integrating a very high variable renewable energy. A lot of wind farms are available in Tamil Nadu. That is also getting pooled here. It controls the voltage of AC bus through its unique features of using the reactive power up to plus minus 1100 MVAR. It uses 2 meter of ROW in the underground cable section of the VSC That is the bare minimum to transfer the 2000 megawatt power. It has the major components like gas insulated substations, IGBTs, insulated gate bipolar transistors, converter halls, converter transformers, control panels, and most of the equipments have been made in India under Atmanirbhar Bharat. The challenges we faced in Kerala were there was a heavy flood which never happened in the past 100 years. So the route got affected of the cable route, and to minimize the time lost due to this lot of machinery and lot of efforts were made to make it fast by using the dewatering and making the land filling. Then we faced a lot of ROWs in Kerala. So to overcome that, we had a tripartite agreement with NHAI and their concessionaire so that we could use the right of way which NH 544 has. And through that right of way, we could put this cable. And during the laying of that cable, the hurdles were there in terms of terrain. So the configuration was remodified from 1x4 to 2x2. So these are the ways in which uniqueness has been made. And this kind of project, which has been brought first time in the country, had its own challenges, but it was very much overcome with the help of the local administration and of course the government of India. Another challenge faced was due to the COVID-19 pandemic. So we had to ensure the availability of the laborers and their movements, as well as the expat manpower who were helping us in executing the project. So the localized food arrangements for the stranded migrants were made. Their habitats were made so that they are there safely. Their health, their hygiene was taken care of. The experts were made to stay back during the pandemic with the support from MEA, Government of India. And those were done with that. This project could be done in such a short time with so much of hurdles faced. This HVDC VSC technology is very unique technology, and it has opened several avenues for improvement in power transmission, mainly in the eco-sensitive locations, ROW intense locations, places of RE evacuation. Now the RE generation is moving very fast, and it is by 2030 we will have 50% of the RE generation. So, and we are also venturing into the offshore winds. So there the applicability of VSC goes a lot. It also provides the opportunity to overcome ROW issues on the stretches, and we can use the cable so that the ROW, which is mostly in the range of say 45 meters to 50 meters, it comes down to 2 meters. It ensures the protection of minority stakeholders while minimizing the forest area. The transmission losses are minimum, and the reliability of power is much higher. So in the future, we are going to adopt this technology on another very challenging project coming up, that is the evacuation of power, renewable power from Ladakh region and to Haryana. So this technology we will be going to use, and the reason being is that RE park is not synchronously connected to the all India grid, and this VSC based HVDC is being used to address the low short circuit levels and absence of synchronous generators at Pang RE park, and it provides the seamless connectivity. And further, the offshore winds, as I have said, which will be coming up in the coming years. So there also the VSC technology is going to be very, very handy. I will show you some of the pictures. This is a typical substation control area where you can see the converter halls, DC yard, and the filters. And this is a view of Pugalur station where it has both the VSC as well as the conventional HVDC station. And then these are the converter halls for LCCs as well as for VSC and IGBTs. So this kind of project has been a very unique project, and it has given a great experience, and it will help the country in evolving further in doing the renewable generation, bringing it much faster through this kind of technology. This picture shows how the 320 kV underground cable has been laid in a 2x2 configurations. Thank you.
Thank you, Anubhavji. Very good project. But what was the reason for taking underground cables?
So reason was number one, Kerala has a lot of forest area, as well as the right of way was very, very severe. So to construct the transmission line through the Kerala was very difficult. So then it was decided to adopt the cable technology, which will involve less right of way. And that's why if you can see that the stretch of about 28 kilometers, we have used this cable to overcome this kind of hurdle.
Okay. And what is the total project cost?
Sir, the Thrissur VSC project cost was about 5,400 crores.
Okay. Good. Thank you, sir. Thank you, please.
Thank you, sir. Thank you. Thank you very much.
Sir, what is the relation of this technology with renewable energy integration? I couldn't get that.
Okay,
how exactly it is helping it out?
Right, sir. Sir, like renewable energy which is being generated through solar or through wind, here, sir, variability factor is very large. You know, the intermittency, the wind is here, then it goes down. So the power flow is not very consistent. Similarly, in the case of the solar generation, the power generated is not consistent at most of the times. Sometimes it is there with good intensity, sometimes it goes down because of clouds. And so this VSC helps in mitigating this kind of intermittency, because it has a feature of controlling the reactive power. So that way it helps. Moreover, it also helps in if the voltage goes down, so it keeps on connected with keep the things connected with the grid, and it doesn't transfer immediately to the other side of the AC. So that way it gives protection as well.
But in your presentation, initially you said that 6,000 power being transmitted from Raigad to Kerala and Tamil Nadu.
Right, sir.
So this project is basically to transfer the power 6,000 megawatt.
Yes, that entire scheme is to transfer the power of about 6,000 megawatt generated at Chhattisgarh to the southern part of the country.
Yes.
Here, Tamil Nadu is taking a share of 4,000 megawatt, and Kerala is taking a share of 2,000 megawatt.
Okay. So what is so special about this technology? It's simply a transmission line, which is which you are using to supply the power to southern region from eastern.
The specialty, okay, sir. The specialty is that, sir, in the HVDC technology, sir, the specialty is that it's such a long distance transmission. The first part is the costing part. The DC transmission becomes cheaper as compared to the AC part when we go for the long transmission. And when you are evacuating a power from a distance of say about 1900 kilometers, the losses also are minimum as compared to the AC. So number one, we are benefited with the terms of the transmission losses. Number two, it is more economical. Number three, the bulk power is transferred. Number four,
that is the normal
ROW,
thing.
Right, sir,
Sir,
the ROW, sir, right of way in the case of HVDC is
yeah,
much lesser than as compared to the AC. So that brings less people are getting affected during the
that is
progression of the
correct.
project.
That is correct. It's a part of the technology. Transmission line, HVDC lines or 746 kV lines are meant for this, all these things. So what is so unique about it? What is the contribution of the power grid or innovative aspect so that you should be considered for the award? Because these things are very normal for a transmission company.
So second unique part is the transmission line which has been set up. So the transmission towers which have been designed,
Right.
it has moved through different terrains. It has crossed lot many rivers. So,
Oh, okay. The area you are talking of is not that much difficult in comparison to Northeast.
right, sir. Northeast is having a very difficult
Yeah,
area. But here
yeah.
also, sir, this is like we crossed some Tungabhadra river. There was a special mention I want to make. So there it was tower design has to be make suiting to the that
So
river bed.
that is the part of work of transmission company. You have to design if something is very difficult to difficult areas. You need to make some changes. So
Mr.
it is.
Abhinav, sorry to interrupt. I think you need to explain a little bit extra about the voltage source converter. That is the technology. HVDC is well established in India for last 20
Sir,
years.
okay.
Voltage source converter, if you can explain, I think that is
Yeah.
the unique USP of this project.
The part which is you are using for matching the renewable energy
Yes,
is
yes.
that thing a unique thing for
Yes,
you?
that is the unique thing, sir. The unique thing I want to emphasize is the black start capability of VSC, sir. That is something which is very unique. This can connect to a passive network, sir, and it can build up a three-phase AC voltage from the DC voltage. This is very much useful not only for the renewable as well as in case of the grid collapse also. So this is the thing. This is the very unique feature which is going to help us in integrating the with the renewable energy, where we are connecting with say offshore wind or some remote solar generations. So there it is going to be very much helpful. Second part is that, sir, it can work as a statcom. That is a typical dynamic control it gives to the grid. So that is something when there is no active power flow, then also it can be used as a statcom, sir. So these are the 3-4 big benefits for the grid, which is going to help us in coming future.
Okay, but these things are very normal in Europe. Whatever you are mentioning, they are already using it for several years. So usually the
You are
awards are
absolutely
given.
right, sir.
You are normally SKOCH awards are given for very some innovation which is already not existing.
Sir,
So
in India, sir, in India it was not existing, and to bring the new technology, sir.
okay. That part I accept that you have tried to bring in new technology to India. That part
Yes.
is acceptable. Okay, thank you very much.
Thank you, sir.